Hi, everybody. My name is Erin Stanfill, and I want to thank everybody for being here on a Saturday afternoon with me. We're going to talk a little bit about concurrency in Go. So first of all, a little about me. I'm an engineer at a company called Truss. Truss is a consultancy where a lot of what we do is help other companies build reliable ways of delivering their software. We use Go for a lot of that. I'm currently on a project where I'm building a web application. We're using Go for the back end of that as well. It's been a fun language to learn. I've spent about a year learning it. Concurrency, and it is really interesting. So it was a thing I wanted to dive into more. So I spent some time figuring it out, and I thought I would make some use of the time I spent by talking to it to other people. So thanks for being here to help me fulfill that goal. First of all, can I get an idea of, do y'all know Go? Okay, you don't really need to know Go. I will, like most of...
Just Google it, I'm trying to draw the parallel between Ajax calls versus Google.
Yeah, it's just a language, so like all languages are, can be translated from one to another. I mean, in this case, I'm just talking about concurrency in Go. I'm not really talking about where it's being run or anything like that. So it'd be pretty straightforward. So I will say that presentation will be up here probably sometime tomorrow. If y'all have any questions, you feel free to ask during the talk. I'll also try to save a little bit of time at the end. So what I want to talk about today is what concurrency is, because it sounds scarier than it is, I think. I'm going to talk about the mechanisms for writing concurrent programs in Go, because there's more than one, and then talk a bit about common errors that happen with concurrent programs, because I think that's the thing that's tricky for a lot of people. First of all, concurrency is the ability of different parts of a process to be executed out of order without affecting the final outcome. So that means if you have a process and you can change the order you do things and you still get what you wanted, you have a concurrent process. So to talk about a real world example, let's talk about baking a cake, right? So if you take a recipe is kind of like a program. You've got your inputs, you have some steps, and then you have an output, which hopefully will be a delicious cake and not the burnt thing that usually comes out of my oven. Right. So recipe, kind of a simple view of what one would look like. I'm just like taking these steps here and abstracting them, because that's what engineers do, right? We abstract. On this diagram, like time is going this way, so the taller things are things that would maybe take longer. And to bake the cake, I would grease the pan, I'd preheat the oven, I would mix ingredients, and then I would do my baking, then I'd get cake at the end. But I could do it in a different order, and I'd still get a cake. I could start by preheating the oven, and then greasing the pan, and then mixing the ingredients. Or I could mix the ingredients and grease the pan, and then preheat the oven and bake. When I do that, always annoys me, because I end up sitting waiting for the oven to preheat, and I don't have anything that I need to do during that time, which kind of raises the question of, usually when we think about how we do this in time, we would preheat the oven while we're doing these things, and when the oven's preheated, then we can bake, right? So this is doing stuff in parallel. The thing to note here is the reason why we can do these things in parallel is because the order of some of these items doesn't matter. And that's sort of, I want to kind of highlight this difference between parallelism and concurrency, whereas concurrency is just being able to put together independently executing processes, and parallelism is putting them together so that they're running at the same time. And really, if you're going to do something in parallel, it's because it can be done concurrent. So if you're looking at a process and you want to think about performance or better utilization of your resources, you're probably going to want to think about the concurrency part and then figure out what you want to do with parallelism, right? So like I just said, if something's parallel, you might be able to do it faster because you're doing it at the same time. You also might be able to use resources more efficiently. So in a cooking case, once you preheat the oven, it's already heated. You might want to then put something else in the oven when you're done because it's already there. You don't want to leave it preheating for hours while you're doing stuff that doesn't need it, that kind of thing. So it lets you kind of manage your resources. So in Go, there are a couple things I want to talk about here about like how we'd express what a concurrent process is in Go, and how we set it up so that it can run in parallel. And it's kind of interesting because in Go, really, you don't tell it to run it in parallel for the most part. You just talk about concurrency, and Go's runtime scheduler figures out the parallelism. There are some parameters that you can pass into it to control it a little bit, but for the most part, all you need to focus on is the concurrency. So we'll talk a bit about creating concurrent tasks, which are called Go routines. A lot of other languages call them coroutines, so we have to be clever here and call it a Go thing. You know, I'm sure there's some sort of Gopher icon for it. We'll talk about how you coordinate concurrent tasks, and then how you can message between them. So Go routine, it's simply a function that runs concurrently with other functions. It's not a thread. So a thread, you know, is like a unit of utilization of your CPU. A lot of times, like multi-core processors, it's like you're putting threads on different processors. A Go routine is lighter weight than that. And the way the scheduler works, it could put the Go routine that you have started, it could decide to put it on a different thread. It can also swap many Go routines onto the same thread. So it's kind of like a thread, but not implemented like a thread at all. The other thing to think about is they're really lightweight. They use a lot less memory than a thread, and they start up a lot faster. So you don't need to think about managing them. For the most part, the runtime is going to manage them for you. So they're also pretty simple to create. So here's some really hard Go here. This is a function, and there's another function being called. It looks like a lot of C-like languages, right, with a comment. To make it concurrent, you just preface the word Go, keyword Go, in front of the function, and then it's concurrent. So what that means is you're saying, hey, scheduler, run this when you want to, and then you're saying, run this now. So it's not, the bake could start before preheat has finished. It could start before preheat even starts. Just in this execution here, you're saying I don't care when it happens. So make a bigger example of the cake. I've got a simple little simulation here where I have an app that just, a function here that just tells the system to sleep for a few minutes. I'm simulating time because I don't want y'all to wait for the hour that would normally take to bake a cake. I think if you haven't done Go, like this probably looks like a lot of other languages. Func is function, then you've got like the name of your function. The thing that might be weird is the type of the variable that's being passed in here, the parameter, is after the name for it. So duration is the variable. The big thing about Go is it's strongly typed, so everything's going to have a type.
Is that like you have a type on an object? Is that what that is?
Well, it's not really, this is just a parameter being passed into a function, sure, right? And this is just saying what type of parameter that is.
Yeah, I guess I'm curious, like, are there different types under time? Like, is that why it has the dot notation?
I think that time is a module or a package. So just like a namespace in Java. Okay. So like there's probably a way to import it so that we just have had like the bare duration, but I didn't do that. Yeah, and so then I just have a function that just like says I want to do this thing, and I'm just naming it, and for how long I want to do it. It's just going to write out to the screen that it started, it's going to wait, and then it's going to let you know when it's done. So here, you know, I'm just letting it start. I'm going to do the steps we talked about before, ending with the bake. And I can't do this with the mouse, so I have to walk around a bit. So not super exciting. It took about an hour to make the cake. If I want to make it concurrent, all I'm really going to do is take that last thing and add that word Go in front of the preheat. And that would kind of simulate what we saw before in my diagram, where the preheating is happening independently of everything else. See how that works. So you can see it started before the pan was finished being greased, but it started after the grease pan. So again, the order is like just it's gonna be different every time I run it probably. And then also it took some time off. The main thing I cared about here is I didn't start baking until the preheating was done for this particular recipe, right? That was conditioned. So that's great. Yes, sir.
How I know that it doesn't have to start baking before we simulate it?
Because of duration.
Pardon?
Because of the duration, it waited.
Yeah, I'm going to get back to that. There are definitely some bugs in here. It works if you don't change anything. So bear with me. But yeah, I carefully did some math here, and the preheating takes the same amount of time as doing both of these things. So we got lucky, right? And we'll go into more detail.
Why did the bake not start when you guys started the preheat?
I'm sorry.
When it started the preheat, remember the few slides before you said the preheat and the bake start in Concurrency?
Well, in this case, it's not perfect, right? So I'm not saying bake as soon as the preheat. I'm just saying I want the preheating to be happening while I'm doing those other actions. And so there's a little bit, I don't really have them completely coordinated. And kind of the next steps, I want to talk about why this doesn't quite work the way we think, and also how we would get it to do those coordinations. So a couple things that go wrong. What you normally hear about with concurrent programming are things like race conditions and deadlocks. So we're going to go through some examples of those. So first of all, a race condition, simply when the order does matter, right? So in this case, knock, knock, and you get the answer before you actually ask the question. Go is kind of cool because it does have the ability when you're running an app to detect races, and I can show you that in a second. First, I'm going to show you a bit of code that has a race condition in it. There are a couple different types of race conditions. There are data races, and then there's just like timing things like I'm talking about here. So first one, I'm going to do a bake-off. So let's have a bunch of people cooking at the same time. And just to make it simple, they all have their own ovens, so we don't have to worry about like fighting for the resource of the oven. So another really simple app function is just saying, hey, I'm going to bake. I'm doing those steps, and then I'm just doing, like I have 4 different people baking, right? And I'm calling them all, they're all going off in Go routines, and then it's just going to print out that it's done. That wasn't what I wanted to have happen. So the thing to keep in mind here is those Go routines, the system doesn't care. They're just going to run as long as the executable is running, but the main doesn't really have anything to do. So as soon as it finishes, the app just kind of shuts down. So just kind of show a diagram. Like, I had these kind of complicated things, and I had a main routine that finished really quickly. So as soon as it exits, the runtime's just going to kill off all those other things because nothing cares about them. It just said, do them when you can. There are a couple ways to fix that. We want to coordinate these Go routines, and that will get into the timing issues that you talked about. So I'm going to talk about all 3 of these. I know channels are like the cool part of Go, but it's not the only way to do concurrency in Go. It's worth mentioning these other techniques and where they're applicable. So with the wait group, are any of y'all .NET engineers? Yeah. I'm pretty sure .NET has like a wait group.
Which is going to be my question. Is there a way to share context between executing threads? Because
Yes.
EPL provides you with like continue with and wait while and stuff like that.
Yeah, there are a couple things. So we'll the main thing would be the channels. That's actually a way of literally passing data across Go routines. So wait group looks a lot like the .NET wait groups. It's just a way of saying, hey, I need you to, I want to wait 3 times for me to be done, and then I have a call down here that says wait until those have all happened. So in this case, it will not exit until, done's been called all 3 times, right? And that works. It makes me a little bit nervous because that's a magic number there. And if if all of a sudden Martha's not cooking with us anymore, then So by Martha. Then it never finishes. And we'll talk more about what this error message means, but it's like, it's still waiting because Martha's not coming. So what I would want to do in this case, and also just there's a lot of duplication there. Let me go back and just show one thing. So this construct here where I have a function just kind of being defined inside a function, a lot of languages have like anonymous functions or lambdas or function literals, kind of what they call them in the Go world. So I'm creating the function here and then I'm executing it immediately. So I did that for all the previous three things. That's like kind of duplicate. They're all kind of doing the same thing. I just did that to group the done inside the Go routine. So what I would consider doing would be like just have that in a function and then pass in the name of the baker. So here I'm just going to create like an array of bakers, create my weight group, and now I know that the weight group's tied to the size of that array. That seems a little less brittle, right? And then range is an iterator in Golang, so it's just giving me a way of looping across them. So this is just going to, create a Go routine for each baker and do these things in it. And then the wait's going to wait for the model to finish before it exits. Right. Except for, again, it doesn't really do what I thought it would because Martha's doing all the work. And that's kind of a thing, it's a gotcha, right? So here where I create this Go function, and inside the function I'm calling baker here, it's passing that baker in by reference. So when it creates, the first Go routine it creates, it just passes a pointer or a reference to the variable. I'm sorry, did I hear a question? Okay. It's passing a reference to that, and then all the functions have a reference to the same variable, and that variable is being moved by this range. So they end up being invoked more or less with the last value. So just a way to kind of clean that. This is the same function, just talking about it again, because I duplicated my slide. So a way around that is that function literal. If I create a parameter for it, and then I pass in the parameter, then it's going to get bound at the time the Go routine is created so that it will invoke for each of them. And that should work. So now I'm getting what I wanted there, right?
Just a quick question.
Yeah, sure.
I'm trying to follow the code and you at the same time, so please forgive me if you've already covered this.
Okay.
What's the underscore comma for and the for?
Good question.
Yeah.
All right, so the for loop here.
Yeah.
So the range creates like an iterator on this, which is, and then it returns. So in JavaScript when you have like a for each and you give it an anonymous function, it takes 3 parameters,
Sure.
and the first one is I think the value, and then there's like the index of it in the array, and then the whole array for some reason. Well, the range returns, for each call, it returns the index, and it returns the item.
So the underscore would be the index if you were going to use it.
Right, but there's this Go convention of if you have a variable that you're not going to use, you just name it underscore.
Okay.
Because it complains if you have a variable that you don't use.
Okay.
So it's just a way of saying throw this value away. Good question, thank
and
you.
Lastly, I'm right on the cusp of completely understanding this. How exactly does the done and the wait work together again? Because it looks like the done is being done inside of the loop, and I'm just trying to understand if that's being called for each baker, or.
Yeah, so this loop here is creating a Go routine. Right, and telling the scheduler, go do this when you want. And what effectively is happening is that Go routine, the first thing it's going to do is call that bake cake function. Then it's going to say I'm done. It's going to tell the wait group that I'm done. The wait group, it's also just under closure, so it's being passed by reference into here. So when we went back to the original.
Is that done being called for each baker?
Yeah, it's being called like, so every invocation will run both of these functions.
So that go func with the passing in the baker can be compared to JavaScript as a self-evaluating, self-calling function.
Yeah, the function literal here.
Right.
Yeah, it's just like an anonymous function in JavaScript. Yeah, so I could have created a named
I
function,
see, yeah.
but
And then you have to call it.
yeah. So another way to do it would be to have like a function and then just that does this and then call it. But it would have been a little complicated because I would need to pass the working group into the function as well.
And so
the wait group.
waiting for all the dones to be finished, or is that kind of how it's working?
Right, because the add here tells it when you say wait group add 5, it says when you get to a wait call, it's going to block until done's been called 5 times.
I see, that makes more sense now.
Okay.
Thank you.
Sure. Any other questions? Yeah.
You continually call that, so instead of calling it up front with the number of bakers, you can call it in your loop every time you add a baker?
I don't know. We could try. Let's see what happens. How's that for brave, right?
I'm thinking of like a case where you don't have an array or something that you iterate over that you don't know the
Yeah.
length.
So let's see. I think this was the one where I added stuff.
If you add it in the loop before you create the garbage,
So let's go see. Oh.
but if you call add in one before you start the governance, you should increment them up and then they should peel off.
So I suspect you could. So let's go see.
Live coding.
So now this should work okay if the hypothesis of it does work is true, because I have a 1, then I have another 1, and we're calling done twice. So it might work. We'll see. I should have asked people to place bets.
I got 5.
That seemed all right. Let me see what happens if I make this a 2, because I'm curious if it just like replaced the value versus. Yeah, it looks like it just replaced it. It didn't. It's a poorly named function, I would argue now, because add feels like it'd be additive, but it's actually just saying this is the value that I want.
Well, you're waiting for 3 now, but you're.
Is it waiting for 3? Yeah. So.
Isn't that the same error you got earlier though?
True. So yeah, so I guess you could in each of these calls start with an add and then end with the done. You can also do, there's like the syntax, it's kind of like a finally clause where you say at the last thing you want to have run is this line that,
That's cool.
you know, so it's just a way to like guarantee that you don't forget to type it unless you like are trying to do live code and you type it wrong in some way. I'm not quite sure what I did there, but I was trying to avoid like throwing too much, syntactic sugar into here. So we're gonna pretend that worked. Y'all good with that? Okay, thanks. All right, so the weight groups are, have I broken my thing? Cool. All right. So, is all this magic not seem magic anymore? Is there something, do we want to like deconstruct the magic a little bit more? I can do Penn and Teller maybe. Okay, cool. All right, so to go back to the point earlier, like that example is all working because 18 is equal to 3 plus 15. So if I actually know how to cook and it doesn't take me 15 minutes to put together cake mix, then we get into that situation that I was hoping that I thought I was avoiding of having the preheat finish in the middle of the baking, right? That's the way I normally cook, which would explain why no one comes to my house. All right, so there are a couple of things like when you're thinking about this, really what we're thinking is both the preheating and the baking both require the oven. They can't happen at the same time. So we want to think of that. One way to think about that is think about it as a shared asset that we need to manage access to, right? The traditional way you would do that in a lot of languages is to put a lock on it, right? So Go has locks, it has mutexes, just like most languages that do threading. And so you can simply have a mutex. So I've got this simple use oven function that you call lock, you do your work, and then you unlock it. And if something else tries to come in here and it's already been called, it's going to block waiting on the lock, right?
But then you don't have parallel, you don't have multitasking.
I beg your pardon?
You do not have multitasking. If you lock stuff, you wait until this job is complete. It's not run. It runs sequentially.
Yeah, it's just a way of saying, you know, it's not about the timing, the order, it's about this thing can only happen.
Right, but usually mutex is done for like writing to the file or something like that. So here you're like every task you will be locking and not allowing another task to run.
Well, I'm only locking two of the tasks, right? I'm only locking when I preheat, and I'm locking when I use the oven. The greasing, the pan, and the mixing ingredients are free. So if I run these, those two, like, it should look like my diagram where I have the preheat happening while these two other things are happening, more or
Right,
less.
but if you have do and do without go up front, it doesn't run in parallel, right?
I apologize, I'm hard of hearing. And
No, what I'm saying, you have do and do two times, grease pan and mixed ingredients. There is no go up front. I thought if you have go up front, it runs in parallel.
Just go use oven.
Is that still concurrent?
Right,
Yeah.
He's questioning the go do. You don't have go do. You just have the do call. So you're just doing the do action. You're not doing go do.
Right. Oh, here on those, because I kind of, yeah, I could put go in front of them. Let's see how it runs without it, and then we'll see what it does if I do that. So, and I can also, there's a way of running this where it reports what the scheduler is doing. I mean, that gave me the results I wanted, but if I put,
This is what she meant, you know. The idea is to show that you can run them sequentially or not, but you can carry more than one task at the same time.
No, but it doesn't carry one task. It's carry one task of 18 minutes, then 3 minutes and 15 minutes.
It doesn't matter the time, they're being carried out sequentially. Do you do go at all?
Yes.
Use oven has go in front
Sequentially.
of
What's
it.
the point to do sequentially?
Do you do go at all?
I don't do go.
Then I don't think the question is.
Why it's not? Why not?
Because
I didn't see
this
music.
is crashing a talk and mansplaining someone. Should just let her do a talk.
No, I'm asking.
I'd be happy to talk about it afterwards. Are we okay moving forward? And then we can talk. It'll be easier for me to talk to you directly. Thank you. All right, so the lock, I mean, the lock will do what we wanted. Like he suggested that, and I did it over here, not here, so you don't see it. Hold on. So those can all be spun off into separate Go routines. I can mess with the times however I want it there so that they don't like add up in some magic way. They're less dependent on each other. The dependencies kind of clearly marked as the oven. I know that I want to do that. There is a different way to model this though. And to start with that, I want to talk a little bit about what channels are in Go. So channels are more about how a Go routine communicates with one another. So I know someone asked a question about that earlier. And effectively, you create a channel by using this make channel, and then there's two operations. One is a way of passing information into the channel, and that's this arrow. So in this case, I'm saying I want a channel that's a string. Channels can be structs. They can be any type that you care about. In this case, I'm just doing string because it's an example. So I pass the string into here, and then the way you receive data is similar, same arrow, but the channel's on the right instead of the left. So if I run this, it's spawning a Go routine for this. It's going to block and wait until that's done before this gets to run. So it's going to end up waiting for that value. And that's, I mean, sort of as simple as hello world. It's just worth noting that those are two separate Go routines running. You've got your main, and then you have the other one doing that to pass that back and forth. So a different way of modeling, rather than thinking of the oven as a thing that needs to be locked, that you only have one access to, you can think about the recipe as the preheating step is creating heat, and that the baking step needs heat. So you can think of heat as a message that's being passed throughout the application. So a way to do that would be create a channel that's, do I have heat? That's a simple way. You could do something more complicated, like if you wanted to simulate like it actually getting hotter, and you could wait for it to hit a certain temperature. But in this case, that's what I'm doing here. Again, I have a Go literal that is doing the preheat, and when it's finished, it's going to send a message through the heat channel saying that it's done. And then I have a Go literal around the baking part that is waiting to receive that message. So this won't actually start, like this Go schedule, I'll have it sitting there, and it'll be waiting for that message to come through.
So does the heat thing have to be a Boolean, or I mean, what if you had like a temperature? You're waiting for a certain temperature?
I'm sorry, what?
Does the heat channel piece, does that have to be a Boolean, or can it be a number like wait for the temperature?
It could be anything, and I'll have some more examples that are using different values. This was just a simple start. So this one I'll do in a second that's sending more than one signal, more than one message through it, and it's a number. But you can also, a common use for channels would be like if you're making async calls on a web server. So like if you're making calls to an API, you pass in a channel that is a type that will hold all the information about the response code and the body of the response and headers and things like that. So it can be any sort of type that you can create and Go can be turned into a channel.
Like again, I'm not sure if you explained this already, but the arrow next to heat at the bottom in Go func, what exactly is that doing?
Okay, good question. So here,
it's like giving it two heat, correct? Like true.
It's saying I want to. It's saying I want to receive what's in the heat message.
Oh, I see.
Channel. And in this case, I'm not doing anything with it, so I'm not setting it to a variable.
Are you going to have an example of that, though?
Where I set it to a variable?
Yeah.
Yeah, so here, I set it to a variable, and then I can just print it out, right? So it's the same thing.
What's the point of what you're doing, though, in the next one? So, for my question, I'm just trying to understand that.
Why am I doing it?
Yeah, is that just a convention, or is that just even...
I am doing it because the convenient thing here is channels block unless they're buffered. So this call here, like if there were more stuff in this Go routine, it wouldn't continue until something listened to it, right? And this one, it won't do anything until it receives something. So it's a way of coordinating that when this function ends, this one can start.
Okay, I think I get it.
Okay, does that help? Yeah?
But can it create one more process like using forking and C? It can create another child and father kind of all functions.
So you're asking, can you pass more things into it?
Not more things. Like you can do fork to create an extra process, right? Like extra copy of that code kind of, right?
So do you want to fork it?
Yeah.
There are ways to do that. I'm not going to talk about them here, but we can talk about it later if you like.
Okay. Does it support also socket mechanisms? Socket, opening sockets?
Yeah, I mean, there are a lot of there's an advanced talk that Rob Pike did on various other things and models that you can do here. I'm really just trying to cover the basics so that we can talk about the 3 different basic, just getting people started. So just run that. We're getting kind of what we expect there, right? Right. So like I said, the channels are blocking, and that's kind of why it's working. So here, it's really the same example. I'm not going to run it again unless someone's dying to see it. Okay, cool. So we could think about some of the other conditions. If we were trying to be our simulation more realistic, like you're not really able to. You really aren't going to be able to bake until you actually have the batter in the pan, right? So you could have kind of signals for all those and wait for all of them if you wanted here, which would just kind of make that more accurate. So, so if there were other variations that happened, you wouldn't end up in a situation where somehow or another you started baking before the, yes?
So the way you have it arranged, it won't run this function until it has a message set in all 3?
Yeah, well, strictly speaking, the way this one's written, this won't continue until, like, heat has to be run before it even listens to these. So it's not super great because it's like these other, if these went to do other things, they're blocking, so they're left open. There is a construct that would allow you to, like, multiplex and listen for all of them and just do some, like, so that they don't block. Yes?
Is the WG done still needed? If it's the channels are gonna make it wait? The WG done?
Yeah, that's the, so kind of like the example before, I'm still using like a done in here for the wait group. And I think it's not really necessary, but that's just, so I suspect that, let me bring up all of the code for it and see. Right, so the present tool that I'm using is letting me exclude some stuff. So ahead of that, I set up a wait group and said to wait for one thing to finish. I could have used a channel for that as well. I didn't in this case. So.
Okay. Because the channels are only making the asynchronous functions wait. But could you use the channel to make the entire process wait to me?
I mean, I think the main reason why I have the wait group here is because I'm invoking all these as Go routines. And if I didn't, then it'd be like that first example where the main just exited before it was done. But I could have, again, created another channel for cake and had it not, and then waited for the cake here if I wanted. It's just, I'm just kind of doing it both ways.
But you cannot put these channels on one line and say, hey, heat and butter can be done separately at one time. Can it be put on one line, this and this?
All those, no, they need to be on separate lines. Let me get my slides.
It's allowed to put on one line with and or something like that.
Yeah, I'm not sure.
I don't think it would make a difference anyway.
No. So, okay. All right.
Would you like us to stop asking questions so you can wrap up and ask questions?
Yeah, I want to make sure that we have enough time to finish up. So I think we're getting there on this. So again, so this is kind of to your question. Here, this would be just like having a cake that would block on in the app and not using the wait group. And I'm just kind of in line here receiving the message so that I can write it out, right? And that's just kind of more examples of taking the received data and doing things with it, like what comes out of here is just an object that you can do things with. To the question before, there are ways, like if you wanted to create a channel that was an integer, this is kind of a function that's kind of doing like a preheat where I am pumping a bunch of different values into it. So let's say I wanted to get to 450. This is just going to emit a message to the channel at every 25 degrees. And then when it's done, when it hits that max temp, then it's going to close the channel. So this here, I'm using a range again, which is an iterator. And with channels, the iterator just returns the value. It doesn't return that index because there isn't an index. Here, you're just going to print it out. So it's just looping through all those. The range is useful for things. It's also just to let you know that the channel's not a one-time thing. You can also do like a buffered channel where it's not blocking, but they're kind of rare cases where you'd want that. The other kind of operation that you'll have around selects or around channels are select, which looks a lot like a case, and this is the multiplexing that I was talking about, where I have several different types of channels. I have the heat, and I have the batter, and I have the pan, and I don't want to block on them necessarily. I just want to, like, as soon as one comes in, I want to respond to what it's done. So in this case, I put it in a loop so that it will run until all three have executed. Sometimes you'll see, like, let's say you're building a web server from scratch. You might put that in an infinite loop, and it's listening for different messages and responding until you kill the app. Right? So just, those things could change a little if I had tweaked the timing on them. So, like I said, there are like these three methods that you have for coordinating your Go routines. You can do the wait groups, which create those barrier events. You can use mutexes if you're controlling access to variable state. You can use the channels if you actually want to be able to communicate data between your Go routines. Mutexes are really great for things like caches. The channels just give you some different avenues that might be a clearer model for what you're trying to do. So what you want to do is think about the process you're trying to build and what makes sense based on these characteristics. So let's talk about the other thing that can go wrong. I think I've had a couple happen in here with the deadlocks. And that's just like the wait group that we talked about before, where like the counts got off and it just sits and runs forever. The nice thing about Go, I guess, is that if all of your Go routines die, it tells you. It doesn't just sit there, because I've had many C applications that just sat there and you weren't sure if it was still thinking or if nothing was going on. So that's handy. If you do have something else still running, it's not going to give you that messaging. Just want to point out that even though deadlocks have the word lock in it, you don't have to have a lock for it. So you can create, here, you can have, this is the obvious case of a lock where you've locked something and then you try to lock it again and it's not able to continue because it's being blocked. So getting that same message. Is that clear to everyone why that doesn't work? Okay. Yeah. So again, you can have a deadlock with a channel as well as the wait groups. In this case, it's because this blocks until it's received something, and these are both happening in the same Go routine, it's never going to get past this, and it's just going to sit. In this case, it's pretty obvious once you get used to the syntax that something's not right, that you're both receiving and sending in the same Go routine. But it's a thing to keep in mind. If you build things with channels, then you want to make sure you know who's the receiver and who's the sender. So it's about responsibilities. All right. So these are just basically like things that will give you a sign that you might possibly get a lock. If you have mutual exclusion of some sort, if you have something that holds on to an asset and then waits for something, and there's no way to tell it to let go, and especially if you have something holding on to something and waiting, and something else is holding onto the thing that it has, then you're going to end up with a deadlock. So basically what I want to talk about, I just want to make sure that everyone understood how concurrency works and how it can enable parallelism, and then talk about these 3 different methods for implementing a concurrent application in Go: the wait groups, the channels, the mutexes, and to just let us think about how we want to model things so that we can be conscientious about how we deal with shared state. And that helps us to avoid race conditions and deadlocks. I've got a couple of resources that will be useful. If you haven't done Go before, the tour on the website is pretty good. I also really like gobyexample.com. It has a bunch of little apps that you can see on one page for various topics. If you really want to know everything about concurrency, this is a very good book, Concurrency in Go specifically. This is a very good book that I believe O'Reilly published. There's also a really interesting talk from GopherCon last year about how the scheduler works. So I'll post these slides up so that you have links to those blue pieces of text, which would be better than pictures of them, I'm sure. That's what I have for you. I appreciate you all being here. Thank you all very much.